Welcome to Tech at Lunch, the podcast that satisfies your hunger for all things tech while you enjoy your midday meal. So grab your sandwich, tune in, and let's dig in. Hello, I'm Nick.
Hey, I'm John.
And, Ed couldn't make it this week. Had a, I guess a water issue that knocked out some power to part of the city. So, he's dealing with that. Row your boat. Hopefully not, but
I think some of the areas have started getting their power back, so let's hope.
Yeah.
Crossed.
So see how that goes. We'll see how his boil water advisory goes later too.
I mean, we live in marshes, so it's prone to flood.
Yeah, exactly. But we've done a lot of talking about the trip that me and Ed did up to South Tech and stuff like that. But we kind of departed from our sustainability conversation, and we kind of want to rotate back into that. We want to continue on the sustainability for additive manufacturing. We will eventually get into some sustainability for subtractive manufacturing.
Oh yeah, that makes sense.
Because that's when it gets a little bit interesting.
A lot more work to do.
Yeah, a lot more heat.
Yeah.
Turn things into bars, pretty much. And the thing is, you start dealing with that with like chemicals. Is how do you deal with the oil compounds and stuff like that?
It's probably real similar to how. Yeah, I mean, Oh, this is a rabbit hole, by the way. You're
start with one.
Yeah, right. You're thinking about like converting something from a solid to like a powder to like maybe even a liquid back to a solid. When you do these phase changes, it affects like there's a reason why when you heat like plastic, any type of plastic, and then let it dry, or glass is a good example. You have glass that's really really cold, really hot, and you throw it in an ice bath, it'll shatter, and vice versa. It's the temperature change shocks the system, right? And I mean,
Prince Rupert's drop.
Yeah, it's crazy. When you do things like that, if you have to think about it on subtractive, it's such a larger scale because you're taking away a lot of a bulk product. Instead of additive, you're using what you need. It's kind of scary. I mean, but I think it needs to be tackled. I mean, just because the problem is scary doesn't mean right you'll avoid it.
The thing is with like subtractive is a lot of stuff you're doing with cooling fluids, and stuff like that. So now you have oil-based lubricants and stuff like that are on these metal shards that now before it even begins the phase change, you have to remove the oil base.
Yeah, I mean, you talked about what was that one bit, the melt-IO thing?
Yeah.
Yeah, so it's transferring the heat to the bits or
the weld wire.
There was a word that you were saying that for what gets taken off of a print.
Oh, it's the pretty much the junk, the excess.
There was a word I can't remember. He said something like scientific. It sounded.
He used a smart word.
Yeah, but that's fine. I mean, like honestly, we should sustainability should be approached for everything.
Yeah.
I mean, we talk sustainability with all the consumables that we touch on. I mean, you think about it. What is something like maybe you've heard it too. My family, they have worries when they heard me 3D printing and had questions. Like, okay, what can you make? What can you do? Stuff like that. Like, what are you printing out of? How durable is it? Then it starts building and they start asking and getting more curious. But, like, we all get around to the food thing and it's like, oh, can you 3D print your utensils? Or, like, can you 3D print like cups to drink out of, stuff like that.
Mine just go glass eye.
Yeah, so you start getting it. There's where the line is, and it's kind of like gray, to be honest with you, because why not? Why couldn't you?
I think my dad asks more questions than most people do about it, just because he's curious. And my dad works in convention building, so it's like you start talking about 3D printers and stuff like that, and he goes, "Ooh, okay, that can make my life simpler." Or, hey, can like I was talking about building him like shelving unit things for his little crash box he's got to work.
No.
And he goes, oh, how long would that take? I said, just a few minutes. It would take you longer to ship it to you than anything. He ended up ordering them off Amazon.
It's easier to have something that's already pre-made. You
right.
Take the piece.
But the thing is that's here nor there. It's just something that people get interested in. My dad is his family is very engineering backed. But with everything going on with NASA and all that fun stuff. So when you start talking about 3D printers, people's minds kind of start tingling. It's like that sense, Spidey sense. But speaking of engineering, we are going to kind of, I guess, head down a different rabbit hole today. And pretty much we're going to focus still on our sustainability side of the house. But we kind of want to close the door halfway, I guess you could say, on our topic on filaments. Not all the way, because there's always something new that's going to pop up that we may bring up in a different conversation. Say, hey, have you tried this yet? And we may grab a roll of it, or a small roll of it, depending on the cost of it, and try it and see what the heck happens. It's one of those, what can you print with this? Believe me, John's been trying to print polycarbonate for the past, 6 months.
I gave up. I got polycarbonate stuck in my mosquito hide, and I'm not happy about it.
Time to heat that damn thing up to 500
Yeah, I got
degrees.
it. Time to get the torch out.
But the thing is so this week we're going to talk about engineering filaments. Everybody hears engineering filaments, and they all go, "Ooh, wonder what that is? Metal?" No. Yes and no, I guess you could say. Yes, metal would be considered engineering filament.
And you're getting on the industrial level, so I would say, like,
right, industrial.
I would hope it's not just Joe Schmo. that's not an engineer at that level making something out of metal. But you never know.
Yeah, you start having layer shifts on certain metal parts, and next it's all downhill from there, literally. But we start dealing with some of the more fun stuff that I guess we have to eventually dive into.
Yeah, it's not easy for, I would say it's not easy for us to speak on some of the engineering filaments or the higher grade, because not necessarily that we, I'll be honest, I can't print these things. I don't have the means, I don't have the machine to do so. So some of the experience is definitely lost there, but when we do research and we look up some of the points and why we choose certain filaments, you boil it down to the PLA PETG comparison for basic printing. It's about the glass transition temperature on the bed when it sticks. It's about what temperature does this print at and flow at. What is, like, when it gets viscous, like, is it going to move by melting it to 230 or 250 or 260 Celsius, right? So we learn those things at the lower levels, and we've talked about this before, where you take those skills you've learned and you can just apply them to the higher not metals, well, I guess metals too, and the engineering and the up filaments, because they just need to be printed at higher temperatures. What the goal is, and what we should all kind of, I guess, understand about the filaments, is that most filaments, you said it before, they could just come up and get created every day,
right?
Because they're created to address a problem instead. So the filament is part of the solution, not just the medium of the solution, right? Not just what the solution was made of. So the print itself becomes just as important, that it is temperature resistant, it's impact resistant, it doesn't break down. So with those things, I kind of look at PEEK as one of the top things, but when you start combining polymers, you start coming up with new types of polymers that address different things, which Markforged has a filament, I'm not even sure what it's called, but it's flame resistant. Yeah. So that was a polymer developed specifically to combat continuing and catching a fire. So it'll put the fire out. So almost like it's self-lubricating type situation, right?
Right.
So, but at the end of the day, that's the gist and kind of the jumping off point. So I would say take everything with a grain of salt, because I've not printed in PEEK.
Yeah. And the thing is some of the stuff that we've kind of gone into. The thing is, when you start thinking about engineering filaments, some of that can start all the way down at ABS. Yeah. Because ABS can be considered engineering filament depending on what world you're in. Yeah. And then move its way up. We both have a good amount of experience with ABS, and stuff stinks. And then
it all stinks.
Well, I think the worst one is the one I got sitting over here on the floor. Yeah. Is polypropylene. Stuff is terrible. Yeah. And the one thing we got to think about is, once you start getting these higher filaments, like PEEK, polypropylene, PEEK CF, and stuff like that, you start also dealing with like pieces of filament that can only stick to themselves. For example, polypropylene has to be printed onto polypropylene.
Yeah.
Or it won't stick.
Well, it's about those characteristics we talked about.
And I think, if I'm not mistaken, PEEK has to be printed on PEEK.
I'm not
for it
sure,
to stick.
To be honest with you, I'm not sure. I think there's some of it is like they're already like pre-cut sheets.
That's what I have on the Ender 3.
So or they're pre-cut sheets and they're what is it, binder jetted. So some of those materials are also made in those layers like that. So I mean, there's different materials, different ways that these get made. But you're right. I mean, there's different byproducts as well that kind of come off them. Kind of to the point that you were talking about earlier is that when we talk printing, your family gets interested. My family's like curious as to what I can make, but they also have the question about like microplastics, and they're like, okay, well, we have Tupperware everywhere. We're talking about like these things don't degrade, blah blah blah. We've mentioned before PLA is biodegradable.
Yep.
We've mentioned before PETG is not as biodegradable, not really at all. You're gonna probably need to recycle that a little bit. But like when you get to the engineering filaments, for a filament or a polymer to get to that high enough whatever resistance that you're looking for, you tend to create some things that are resistant to everything, right? So it's kind of a byproduct of making your polymer more advanced and more durable. It's gonna last longer.
Yeah,
I mean, it's the part of the goal.
You start getting into the whoops, what the heck did I do?
Yeah, what have I done?
Well,
I mean, that's the goal. You want it to last longer. You want it to take the impact. You don't want it to be like, you don't want it to break the first time you use it, because then what's the point of printing? It's all for naught.
Right.
So, yeah, I mean, that's the other side of things, is like being conscious to, what is attainable and kind of what you can. I don't know what you can take care of or what you can recycle instead of just making just to make stuff. Sometimes, I mean, I guess more of what I'm trying to say is have a plan for your project if you start printing and things like this. I mean, rapid iterations are nice, but every time I print a model, I save that model to show off somewhere later. I'm like, oh, this is cool. I'll leave it on my desk. Yeah. But what happens when you do hundreds of those and you start throwing them away each time you want a new model?
And the thing is that touches on a good point, is start with the lower filaments before you make your final product. Yeah. So it's like, well, I need to test this in PEEK.
Don't make everything out. Yeah, make only the working part, right?
It's like, if you need to test something, if you're printing in PEEK, so if you're using a Stratasys machine, you're printing in PEEK, start with PLA. Print out your test models, make sure it fits and stuff like that, and then print in PEEK for the final couple. And just keep those on, the side shelf, just in case something happens, you can return back to, a known good point. Right. Because you're not using that much filament. Because I'm going to tell you, what I've seen in just by doing a lot of in-depth research, just looking here a second ago on some PEEK stuff, it's expensive.
Oh yeah.
So,
but there's a reason, man.
You ain't going to be using a lot of it.
I mean, this is the stuff that if I were to make like a replacement for a metal, it would be made out of a carbon fiber PEEK or a nylon PEEK or something similar, like engineering type filament. Because like hell, we've seen even some leaf springs have gone to a polycarbonate or a poly some type of polymer versus the full steel springs. Or steel leaf springs, like they're different now. Right. Doesn't mean that they're not more or not durable. I mean, it's the same thing with carbon fiber, like a carbon fiber hood, or like if a bike, an electric bike is made, and they talk about a carbon fiber frame, the density of that bike, if they got off of it, they could probably lift it with a single finger. Probably. But that bike still does the job, right? So I mean.
Yeah. And it's like, if you think about it, I'm looking right here, and this is kind of tells you something. PEEK 3D printing filament, right? 500 grams.
That's only a half spool.
500 grams. It's $357.
Yeah, only half spool.
Now, that's from Filametrics, which is a good company. No. Now, they also sell a full spool of PEEK enhanced carbon fiber. Yeah. At $227 a spool.
Hey, get you a steel.
So, you know, these things are not cheap. They're not cheap films at all. They're not ones that you're going to go out. You're also talking about $5,000-$6,000 printers to be able to print this stuff because they can get to that heat.
Well, yeah, like there's one thing we haven't really mentioned. It's like, so what temperatures are we needing to hit?
Yeah.
And you're asking us, it's like, kind of need to hit like 400 degrees Celsius. Like, that's really fucking hot. And you stand, oh, excuse my French, that's really hot. And you stand chance of burning down whatever facility you're at if you don't have proper precautions and safety in place.
Yeah.
So, like, I would not suggest printing it at your house unless you have a well-ventilated area, unless you have, a fire suppression system, or some type of cutoff, right? So there's like these are things that I would hope.
Yeah, because
you would already have done.
Peak. I'm looking at the Filaments website right now, just to kind of see what's going on. Recommended nozzle temperature for this stuff is between 370 to 420 degrees Celsius. Recommended bed temperature is 120 degrees.
Yeah. So my thermistor or my bed thermistor can't even heat Like, we talk about that temperature, and let's say your print is 8 inches tall.
Yeah.
And it takes a day to print. That means that bed needs to have a level heat, consistent heat, for over a day at 120?
100, greater than 120 degrees.
Greater than 120. I would expect warpage if it's not clipped down.
Yeah, and it might be less than it's gonna be less than or equal to freaking, or maybe more than 120 degrees. Because think about this, I'm looking at it. Your heated chamber temperatures are between 70 to 140 degrees.
Yeah. Yeah, so that's what I'm saying. It's like,
and you're gonna dry this thing at 120 degrees Celsius.
You need an enclosure. Your filament needs to be dried as it goes in, and as it comes out of its spool, and as it goes into the extruder. Like, you'll probably need a direct drive just because it lowers the distance that it needs to push through and have that high temperature. Because I can guarantee you that an 8-hour print will burn your PTFE tube completely. So yeah, just all things considered, if you're at that level, there's a checklist that I hope you'd have already gone through. We talked about it before. If you're not sure how to make a preventative maintenance checklist, go back and look at it. You need to look at your printer, and you need to see what are the dangers of me running this, and what is the benefit, because you have to have the enclosure. You need to monitor your enclosure's temperature. You need to monitor the area around it, and make sure that no one kind of messes with your print. But I highly doubt in Ender 3 that is going to be able to do these things, because you're going to have to upgrade your thermistor, your hot end, your heater cartridge, your bed heater, your bed probably. You're going to have to probably take off your power supply because it's too close to the bed. It's going to be too hot. So you probably need a metal extruder. Like, there's a lot of things that you would have pretty much had to do, and you have to buy almost an entire new printer. So it almost makes it not really a great idea to get the Ender 3 and upgrade it. At that point, I would say you probably want to go for a higher end model, and then just buy like a mosquito hot end with the thermistor that, like, the PT1000 is a temperature sensor that's pretty standard.
Yeah.
PT1000, and you can look that up on Amazon and find it. So it's pretty straightforward. But at the end of the day, if you're printing these higher temperatures, these are the things that you have to do. You have to consider the dangers with all of them, and then you have to think about your ventilation. With you as the user are also very important. Without you, nothing gets made.
Yep.
So if you're inhaling plastic fumes all day, I can guarantee you it's going to have some effect on you.
It's like, I'm looking at the just kind of dinking around Therma X Peak, right?
Stop buying filament. You buying filament over here?
No, definitely not, because I can't print it. So, because you got extruder temperature that 375 to 410, bed temp 135 to 145.
Yeah.
Heated temp 70 to 140. And now you have to print it on a PEI sheet or tape.
What's that? Does that look like something's like bending up right there?
Yeah, that's bed adhesion.
It's telling you need better adhesion or clamps.
Yeah, or you need to run a glue stick on clean glass. Or Ultium PEI sheet or tape.
Yeah, and if you don't put that. So, by the way, guys,
it's a 0.2 layer height or more. or more.
0.2 is about standard though.
Yeah.
But if you have glass, when people are talking about using a glue stick, it's not about bed adhesion. It's about having it as a separation for after the print.
So you don't snap your glass.
So you don't. It will become one with the glass. So just a pro tip right there. Like we oftentimes get mixed up with glue and sprays, thinking it's supposed to help stick to the bed. Yeah, maybe at first, but at the end of the day, it's because you want that off the bed.
Yeah. I can tell you, I know so many people, just talking to friends and watching stuff, on the YouTube and reading stuff online, and people saying, "Oh, well, I just did my first print. However, I snapped my bed that's made out of glass." Well, because you didn't put anything on top of it.
Yeah, chunks of glass everywhere.
Which it happens to the best of us. If you haven't destroyed 3 or 4 beds in the time, guess what? You're not really doing right.
Yeah, it's the same thing as if you're drilling a hole in wood and you don't want to fray the edge of the wood, you put a piece of tape down.
Yeah.
And because the adhesive will catch everything and you'll have cleaner breaks. So, I mean, you just got to employ. I mean, we'll eventually have like a deep dive series about physics of things, but like you just have to think about it, and there's a lot of sense that gets made.
It's like be smart about it, because the thing is, even if you start dealing with in the Voron world, you start dealing with nylons.
Yeah.
And you start printing in a nylon environment. You start printing just that's a beginner. I guess you'd say nylon is your beginner engineering filament.
It's crazy though to think about, because that's not easy to print with.
No. And some people are like, oh, we're gonna print nylon. We're gonna print nylon. Okay, well that's cool. However, nylon is a beast. It's from what I've read and stuff like that, and people I've talked to and stuff we've seen. Even when we went to Rapid, they're talking about nylon is not an easy event.
There's a reason we want to use it, though.
Right.
There's clear benefits of it.
And the thing is, it also shows what type of heating chamber you need as far as for your dryers. If you're gonna make a dryer enclosure, like I just saw one guy make one earlier, it holds 40 spools and it spins.
It's a rotisserie oven. That's what that is.
No, it's not even. It does have a heating pad in it, and it has some decusant.
Okay, that makes sense.
Right. So,
I'm
but
just saying.
It's the problem is, like, if you start keeping something like that in your house, okay, or in your shop, okay, just don't put your peak with your PLA in a 120 degree enclosure, because I guarantee you're gonna get PLA glue.
Yeah, the spool will be. It won't like melt to a goop, but all of your strands of spool that as it was laid down are gonna be melted and together and like fused together.
Yeah.
So you'll have a spool that's like perfectly circle and stuck.
Right.
Maybe a little droopage.
Right. And the thing is that also goes to the fact that sometimes you see people that they're not, they're trying to run, certain filaments, but they want to run the paper spools. For engineering filaments, you really don't see paper spools.
It's tough.
And so, which for some printers are good, some printers not so much. It's like if you start talking about the Bamboo Labs and AMS, you have to have the plastic ring around the outside of these cardboard filaments, cardboard spools for them to work. Also,
it rolls cleaner.
Yeah.
Yes, so I've noticed that issue with the printout that I have, which is just a version of the standard Tushy ball bearing or skateboard bearing, whatever, rollers. But yeah, with the cardboard spools, if the cardboard gets wet, it frays at the ends, and if it's too big, it won't roll cleanly. And it did stop one of my prints because it pulled itself off of the rollers, so I had to bolt it down.
I had the same problem with mine.
Yeah.
It just decided that it didn't want to be there anymore, and
just pulled it right off.
I came home one day and they're in pieces. So it was, playing 52 pickup.
I gotta make another one though, because I there's one that you can bolt down, and that's pretty much what you need, because then it'll just pull the spool off of it instead of throwing everything everywhere.
Yeah, and if you think about it, the funny part is for like my Voron, you're talking about almost $1,000 printer, and I'm using the same spool holder from an Ender on the Voron.
Hey, if it works, it works.
Right, you know. But the thing is like you have to feed it from the back, which is fine.
Yeah.
But that's not here nor there. But the thing is you know we start talking about recycling of these you know filaments like Peak and Peak CF, and you start talking about like recycling of nylons. You start talking about
it's tough, man.
you know deep breath break.
Oh, you good? Yeah.
You know, you start dealing with the polycarbonate ABS, or polycarbonate carbon fiber, you know, and how those have to be recycled.
Right.
You know, we start dealing with a totally different freaking environment.
Sorry, found a sticker on my.
You found a tag, Seth?
Yeah, there's a tag that I didn't realize was there. Sorry, I was like pulling on it. Probably gonna unwind my entire jacket, but no, yeah, I mean, it's not easy. It's not an easy topic.
Right.
They're the most durable filaments. They're the most, they're the least susceptible to degrading. So, like, when you talk about what do I do with it if I don't need this part anymore, or what do I do with it if, you know, if I'm done. For me, reach out to the manufacturer and hopefully they can recycle it for you and give you something worth something. But on the other side of things, that so the FDA has actually approved some Peak implants for some medical conditions or medical patients. So the sustainability is if we could repurpose the filament. And then we can we can use it to make parts that, like, let's say, are needed in the medical field. And since they're highly resistant to biodegrading, they can exist inside a human body for much longer, meaning they can do whatever you're missing, right? The doctor can input it as a spinal implant. Yeah. I mean, I think there's questions that can be said for weight bearing and things like that, but it's a higher durability, so I would hope that it could take at least half your body weight or something like that.
Right.
Like talking about, you talk about your kneecap and things like that. You can reprint that and put a kneecap, if it's cracked or chipped or anything like that. I mean, those are things that, like, you can implant in with Peak that your body won't fully reject, and has been FDA approved, but also will last you quite some time.
And this kind of leads me to, you know, kind of down a different rabbit hole.
Yeah.
Do we, I don't know, I haven't really seen any, engineering grade resin filaments?
I think they're not as tested. I mean, yeah, I'd say so. Polyspectra.
Yeah.
Polyspectra, the core series, the core black core. I mean, the rest of the names escape me, but
the green, the black,
there's a yellow one, but I don't know if they're just color based name. But core COR is I think the base name for a lot of them. But yeah, if you ask me, they make one. Fosen makes an impact resistant one.
Yep.
I would call those engineering resins because these are resins that will have the characteristics that we're looking for, but they undergo a fundamentally different process. However, with Polyspectra, they prove to us that with that other process, they can now create thermal resistance, right?
Exactly.
They can now create higher adhesion and layer bonding. They can create a part that will withstand, you know, pressure better than a standard resin. So for me, I think it makes sense, and yes, they do have it, but I don't think it's as like prevalent as like.
Yeah, because I know about the dental resins.
Yeah, so for resin printing, it's about the resolution, because you can get it very like precise. You can get up to 12K resolution. You can get a very precise part. So if you need, like, let's say, a tooth design to fit or something, like a crown or something like that you're putting in there, then I would say resin print is the way to go, because it's going to fill everything out and be exact. Whereas the filament with the point, unless you have a 0.1 nozzle or smaller, which to me, every time you go half your nozzle, you're you're doubling and tripling your print time.
Right.
So if you got an hour print and you go from a 0.6 to a 0.3 millimeter nozzle diameter, then your print's going to be like 4 or 5 hours.
Right.
So if it's much bigger than that, you can just catch my drift. It takes like a day for a 4 or 5 hour print. Like it's that much longer. So I mean, but you get they're finer lines because it's a thinner layer, and you can kind of adjust things and speed things up so it works a little bit better. But you're working against the physics of the filament and how it cools and things like that, because your natural environment is the best environment for PLA and PETG, but not for some of those higher engineering filaments. Right. This is why we need the enclosure.
And that kind of that kind of makes you wonder. It's like, because we saw the core resin and stuff like that, and we started talking.
Yeah, they boiled it.
They boiled it,
water. Yeah,
which now leads me down the rabbit hole of how do you recycle it and stuff. If you can boil it, it's not going to happen to it.
Yeah, so now you see my dilemma that I have. The question that kind of comes up every single time, where it's like,
well, being a California-based company, I'm sure they have to figure out something.
Yeah, I'm not saying that they don't. They're just like, no, we use these parts forever. They never go bad. No, but seriously, like, the test parts probably get reused constantly, but I doubt that they have a very large unused side of the house. But these guys, we met them at Rapid. They struck me as a very planned and calculated group. Like, there was a section of them that were definitely the thinkers, and a section of them that was definitely the drivers. So that they would drive and push and say, hey, I need this so that we can affect change. Yeah. Bring product to the table. You need to do this.
And we'll have to have them on with us one time just to, have a conversation with them, especially prior to next year's Rapid.
Yeah, that'd be nice.
Before we go out there and have a conversation, out there and, see them again. Because pretty cool dudes, We got
to put some questions together and see if we have something that we want to push the point on, or maybe a product that they have or something. And
then we'll definitely have something probably at the beginning of the probably towards the end of this year, beginning of next. Yeah. Stuff people from South Tech that we're going to talk to. But that's here nor there. It's just the fact that when you start talking about these companies who are making these extreme filaments and extreme resins. These guys they're thinking about all this stuff. They're really getting around to that. It's Polyspectra is a chemical based company. They're full of chemical engineers that started out at just some startup incubator, then went from there. Sense. And then slowly but surely took their what they're doing to the grand. Spec side of going to these shows and being there and showing off. But then you start getting into, for example, like we were talking about, is the ABS based filament. You feel like you figure out what it was?
It's an order code.
Oh, so you have the inspection sticker.
I got my phone number on it.
It was inspected by Bob.
Yeah, I got an inspection sticker. Okay, sorry, it was weird. It was tickling my neck, so I was feeling it was weird.
But the thing is, you start getting into like the ABS type of filament, or resin, the impact resistant.
Yeah.
That stuff can be easily recycled as far as like regular ABS.
Well, that's the thing. Hopefully, once we get into the realm of, we're printing at PLA PETG, we're printing utility parts that use most of the time, I should say. Sorry, there's outliers, of course, but most of the time they use the existing support or the existing structure. So, like, for me, I use PLA to mount the shelf. I'm using the wood mounted into the stud of the wall. The plastic is just something in between that's tying them together, but that's not where the strength comes from, because if I tightened it down a little bit more, I'll snap these.
Right.
So for me, like, once we get into those higher levels, now these become your utility and your tools. Hammers.
Yeah.
Pry bars. Like, these can be wedges. All these are printed now. I bet you can't make a blade, but
you might be able to.
You probably could sharpen it, but it won't last.
Yeah. You can do what you want to do for a little bit.
But you see what I'm saying is, like, when the impact resistance come into play, the temperature resistance come into play. Yeah, I mean, it can be something as like as like every day, like a s'mores, like a marshmallow holder for the fire.
Right.
You're able to put this in the fire though, right? Boom, there's your answer. So like I think we create these things to solve some questions and to solve some dilemmas in our life.
Mm-hmm.
So like I wouldn't be surprised if someone was able to print that they were printing something as small as like a lock for a door, right?
Makes sense.
Maybe there's not like heavily expensive items in there, but like it's a small latch lock that's gonna last. Maybe the latch is outside, so it needs to last outside for a long time. If you make it out of PEEK, you guarantee 10 years life plus. Why not?
Right. And, you know, the thing is, when we start printing PEEK and stuff like that, you also have, like what you're talking about with supports.
Right.
Structures and stuff like that. That's when you start really getting to the fun stuff. You start dealing with, like, the water-soluble supports and like hips and stuff like that, which eventually I want to play with, but, you know, I need a dual extruder to be able to, you know, get close to that.
We'll get there. That's a headache in and of itself.
You know, but... And I just think it'd be fun because, you know, I get this whole entire print. I could dip in water, and guess what? All the films are gonna start breaking off. All the the pieces will be breaking off eventually.
Yeah, right.
So you know, it's less time than having to cut them out with a pair of snips and you know causing a mess.
Yeah, it's not. It's just tough. I mean, honestly, it's a lot of work to do. But like having some supports that'll wash away. You can really have some more complicated structures. So, yeah.
And if you think about it, you know, we start dealing with, you know, film like resins now and stuff like that. You know, as we're talking about the washing away of supports and stuff like that, you start dealing with a lot of your higher end filament resins now are now going to a water soluble, you know, or water cleanable process. And getting more away from the alcohol based,
less toxic,
right? And the thing is that's also one less thing you got to recycle because you're not having to recycle the alcohol. You just kind of you know.
You can actually. That's crazy. You can reuse a lot of that.
Right.
Alcohol. If it's isopropyl, you can really cure. You can leave your bin or whatever your cure tank outside, and it should solidify all that gunk, and it should.
Yeah.
Unless if you mixed it with other stuff, but the resins should solidify with sunlight.
So it's kind of like you know when you clean a fryer, you just kind of throw a couple potatoes in there.
Yeah. Exactly. So you sit like for me, I have like a table like whenever I take out prints from the resin, and I like if I need to take supports and stuff off, if I need to clean or process anything, I have like a baker sheet that I do this in. And then it sits out in the sun, so those things can cure on their own and dry. So yeah, absolutely, it's something that like for me, you need to toss it out and clean it. If I have a bin that I usually using isopropyl to clean off stuff, it's washing off resin that's not cured. So putting it out in the sun, you're just gonna cure the rest of it.
Right.
It'll be weird looking. It'll be like a blob when it comes out, but I'd rather a blob and reused alcohol than you pouring out alcohol and resin into a sink.
Right.
Or another way. I mean, you can't do that. You can't do that.
Right.
Don't pour resin down the sink. It's not good for anybody.
You know, the thing is, unless you're dealing with the ones now where it's like, hey, these are rinsable.
No.
You know, where you don't have to use
there's
alcohol.
new water soluble, so that's a little bit different. But it's the same thing
safer.
with like, it's the same thing with like when they started using where you have like the lighter fluid versus
butane
coals that already have the fluid on them too. So like you don't have to let someone soak things. You take away step out and it's already there. They just gotta light it. So it's a safety step. So like you work it into the process. You force people to have to do the safety step so that they can make sure that your product isn't causing them harm.
Right. And, you know, but that's the fun part about getting into more of your advanced filaments and stuff like that, or resins, is you really kind of get in there.
Kind of hurt you.
Right. But the thing is you get to kind of see the different nuances of the different type of equipment and stuff like that you have to get into.
Yeah.
And, you know, the thing is, you know, I really hope that, you know, everybody who's listening in, you know, is willing to go out and take a look at some of these filaments. You know, these are the type of filaments that you also see that when they pelletize this type of stuff, and through pellet printers, you know, the ones you see on the end of Kuka arms, you know, on the end of Fanuc or ABB or Yaskawa robots, Motoman. Or, the end of just a regular 3D printer robot arm that somebody's swinging around trying to print.
Yeah.
You start dealing with pelletized, filament, and that's when you start getting to some of your higher level engineering filaments, because bigger the print,
yeah,
bigger the size you need, and that's you start dealing with large amounts of like ABS, nylon, and stuff like that.
And this is where you get you're printing aeronautical parts, you're printing marine parts, boats, like it's your bumper for your car probably could be printed at that level. Like, this is the level of innovation just grows, and it's something that's like, now this is easier to do with the knowledge that you had just printing on an Ender 3. Not just that. I mean, you need some extra gumption, but...
Right. And I'm sure we could do an entire episode just on pellet extruders and pellet printers, because that stuff is a very niche environment, I guess you could say. But there's a lot to it. And the thing is now you can even 3D print your own pellet extruder.
Yeah.
You can 100% open source.
Yeah, I was looking for one for the Chiron. I need to do something with it. It's a god-awful machine. Yeah. It doesn't like to print. Longer than like...
Well, you just got to turn it into a big giant ender.
2 hours. It's going to be a giant ender. It has to be. It has to be. I mean, we can get... I don't know if we want to get too far into microcontrollers, but like... I mean, we could deep dive into that maybe on the next one or something like that.
I think the next one is going to be one of our better.
But to be honest with you, I think that's a great example for that episode, and like something to look forward to, because I'm absolutely going to take this Anycubic Chiron. I'm going to rip out its guts, the electronics boards and the harnesses and all that stuff, and I'm going to redo it because Ender did it better.
Yeah.
So I'm going to make an Ender Max, and I've got the parts to make an Ender Max because I've got old broken down Enders. So that's something that, like, it makes sense to talk about MCUs or consumables too. You can go through them. I mean, if you don't know what your pen out board looks like, you can probably even do your own printable logic controller board too, PCB if you want. It's just a controller, but we get into those details a little bit later. So
I still got an extra Ender 3 that I might.
Is it 427?
I think so.
Okay, let me look at mine too. I might have to ask you for that, or might have to try to get that off you, because
I think I only got 427. It might be a 4. It might be. I know the Ender 5 is a 427.
Yeah, I've converted pretty much everything I have to a 42. No, I've got 2.
You just use the big tree.
I've got 2 on the big tree. I've got 1 on the 4.7. I think I might have an extra 4.7 actually.
Yeah, like I'm running the Octopus on the Voron,
right?
Which eventually that needs to
see, and we're gonna go into this is something that we've got to leave for next, because we'll go into details, and there's a reason why we call them these things, and there's reasons why we say one is good for this or that. But so there's a lot more detail to go into.
And I hate to say they're throwaway parts, but they kind of are.
It's hard to reuse.
Yeah, because once you burn them out, you're done.
These are the ones that you would take to your recycler. We'll talk about it more, but we take to your recycler, and they have to like melt it down and sort the metals out.
Or give it to a friend, and they'll fix it for you.
I'll use it somewhere else.
Or use it for their own, devious purposes.
Yeah, you want an orange pie just to see if it works? I can tell you it works. It's just not the prettiest.
Still works, don't it?
Orange pie.
Yeah. But, that's what we'll talk about, I think, next time, is we'll kind of get into more of the MCU side of the house and, that fun stuff.
We could probably even talk a little bit more about not just the MCU, but the host, if you're hosting Clipper. Yep,
because you start really dealing with a lot of other stuff, and you can do off-printer hosting if you really wanted to, and it's going to get a little weird.
I'll say preferable to me. I don't know. Some people fight it, but
it's
not being a dinosaur.
The thing is people are able to host Clipper on small mini PCs, and so they're straight off of the MCU.
I've got a laptop that's from like 2010. I imaged it with Linux Mint. It could be my Clipper host. However, the battery is the failing point. I couldn't keep it running long enough.
So what do? We spend $100 and some on Raspberry Pis.
I'll take that. Hey, woo, it's $40 for an orange pie.
Yeah, it's gonna wait 6 months from Alibaba.
Yeah, it's coming from China. It's definitely.
So, but that's something that we'll definitely dive into next time. I think we've kind of hit the nail on the head on this one, as we kind of close the door, at least prop the door shut, on Filaments for now.
It's gonna slam open again.
Yeah, until we find something else we like. I'm sure we'll slam the door right back open again. We'll start talking about pellets.
I mean, NASA's got some alloys that are just
insane,
crazy. Like they've got the strongest metal alloy, and they're printing it in space.
Yeah,
that's just wild.
So we will definitely slam this door back open again. So it's definitely a prop shut. It's not latched. Yeah. But we want to say thank you to everybody who's listening to us and who's listened to us this far. Listen to us kind of ramble on about this stuff. Get out there, do some 3D printing, always be learning something. Have a little bit of fun with it. Go check out our blog, and go check out Printed Heritage, along with Vulcanar 3D, where you might get some shirts. We're going to probably get we got to get the shirt stuff back up and running again, so you guys get some merch from that. A little bit more 3D printed.
Should probably do it like waves, like.
Yeah, I think we got two or three on them down there now. We'll probably add more later. Just so people can kind of, get, some 3D printed stuff going on, because you really don't see a lot of that. But, the good thing is, the numbers coming up, we're at 2,042. We're rocking and rolling. We're doing really well. I want to say thank you to every single person who's listened to us. I'm seeing some new listeners from some new areas. I want to say, hey, welcome in. We hope that, we kind of help guide you to that, to what you want. If you have any questions, send us a question or comment or something like that. And if you're not in the U.S., which I can see a good amount of y'all are not inside the U.S., send us, what y'all are working on. Send us the type of filaments that you guys have.
Don't worry about converting it to English either. It's fine.
Yeah, we can take care of that.
I don't mind doing a little bit of research.
Or, and don't change it from, the, Imperial to Freedom use.
Please, use Imperial. It's easier for me to conceptualize. Like,
use your local currency, your local stuff, and, just let us know where you're from and, what y'all are working on. Because, to be honest with you, it'd be kind of cool knowing what kind of printers y'all are using.
Yeah, all my schoolwork was Imperial. So
yeah.
It's just easier to do math.
Yeah, I can understand that. So mine's in, supply chain.
Yeah.
Which is not fun. But, I want to say thank you, again, and I want to say thank you to everybody who's listened to us. And, we can't wait to talk to some of y'all. So, all right, from my side, thank you.
Yeah, I always echo appreciation. It's nice to have a platform. We're kind of dropping a lot of knowledge, but if you catch us anything that you're confused on or you think, hey, that's not right, I'm not against being corrected. Absolutely fine with it. I'd rather have clarification anyways. It means that there's less confusion for me, because confusion builds anxiety sometimes. So it's one of those things where if you don't know, you get worried. But yeah, ask. If you don't know, ask. If you have a question, ask. If you're curious about something, ask. If you want us to go in a direction, just let us know. We're fresh minds, ready to kind of help out wherever we can. So once again, thank you to everyone. Check out the websites and stay tuned for more.
Yep. All right, y'all. And also, by the way, I just thought about this. Let us know how you're using 3D printing in STEM in your area.
Yeah.
So, all right, guys. We'll talk to you later. All right, have a good one. Bye.
Take care.
That's all for this episode of Tech at Lunch. Thanks for tuning in and joining us for this tech-filled lunch break. We hope you enjoy the show, and don't forget to subscribe on all channels. And also, you can find us on YouTube under Vulcanar Technology Solutions. And join us for our next episode, which gets published every Wednesday at 8 a.m. All right, y'all. Have a good one. See you later.